Hello students, today we are going to take the next topic of this chapter, and that is parallel lines and transversal. So this is the very best example of parallel lines. You can see here the white lines that are drawn on the running track. So all those white lines that we see on the running track are parallel lines, right? So first of all class, let us define parallel lines. The two lines are said to be parallel when they never meet each other, right? They do not have any common point. They do not intersect to each other. So here let us take one line L, clear? And again draw another line M such that they do not meet each other, right? However, if we extend them on both the sides, if we extend from the left and from the right, then also they will never ever meet each other. So here when line L is extended on both the sides and line M is also extended on both the sides, then also you can see that none of the lines are meeting each other. They are not intersecting to each other. And there is one symbol that we use to represent the parallel lines. What is it? You can see here it is L parallel to M, right? One more very important point related to parallel lines. It says that the distance between both the lines, right? The distance between both the lines remains constant. There is the same distance between both the lines always. So here this is how two parallel lines look like. You can see they will never ever meet each other. Now moving on to another line over here, that is a transversal. So what is a transversal? We say that when a line cuts the two parallel lines, right? When there is a line which intersects two or more parallel lines at distinct point or at different point, then we say that the line will be a transversal. Now how we can visualize it? Let us see. We are having two parallel lines L and M. We say that L is parallel to M. Now how a transversal will look like? It is going to be like this. Line P is over here a transversal. Why? Because it is intersecting the two parallel lines at two different points. Line L is intersected at this point, whereas line M is intersected at this another point. So here in this figure, we say that line P is a transversal. Now in this system of lines class, we are going to have some angles. There are some angle formation in this figure. As the name of the chapter, lines and angles. So here in this system of lines, we are definitely going to form some angles. How many or how we can form the angles? You can see here. Angle number 1, then angle number 2, angle number 3, angle number 4, angle number 5, 6, 7 and 8. So total 8 angles we can represent here in between parallel lines and a transversal. So here we are always going to get these 8 angles. Now we know something about all these 8 angles, right? There are some properties related to all these 8 angles. What are they? Let us understand them one by one. The first property says that the alternate angles are equal when we have two parallel lines, right? So if we are having parallel lines, then definitely alternate angles are going to be equal. But what are alternate angles? Alternate angles are either side of the transversal. They are formed on the either side of the transversal. It means if one angle is formed in the left of the transversal, another angle is going to be in the right side of the transversal. Also, if one angle is in interior, then another angle is going to be in interior only, right? So here let us see. You can see in this formation of lines and angles, some angles are in interior part and some angles are in outer part. That means exterior part. What are they? Let us see. So angle 3, angle 4, angle 5 and angle 6 are said to be in the interior part. Whereas angle 1, angle 2, angle 7 and angle 8 are in the exterior part. Right? So how we are going to mark the alternate angles? Let us see. If I choose one angle and that is angle number 4. right? So for angle number 4, which angle will be there paired with angle number 4 so that it is going to be alternate angles? Here with angle number 4, we are going to take angle number 6. Why? You can see as angle number 4 is formed in the right side of the transversal, whereas angle number 6 is formed in the left side of the transversal. Also, both are interior angles. So here angle number 4 is going to be paired with angle number 6 and both are going to be equal. Why? Because the lines are parallel. If the lines are parallel, then alternate angles are equal. But remember, if the lines are not parallel, then definitely we are going to get the alternate angles, but they will not be equal to each other, right? So here lines are parallel, therefore alternate angles are going to be equal. Let us take another pair. If we take angle number 3, angle number 3 will be paired with angle number 5. And 3 and 5 are alternate angles. So one more trick is there for identifying whether the angles are forming alternate angles or not. You can see over here a Z formation. When there is a Z formation between two angles, then yes, we say that they are alternate angles. Also, you can see S formation. So this is some trick to identify, to check that yes, the angles are alternate or not. One more or two more pairs are there. What are they? Angle 1 will be paired with angle number 7. They are alternate angles. And angle number 2 will be paired with angle number 8. They are alternate angles. And also alternate angles are equal to each other. So here you can see angle 4 is equals to angle 6. Angle 3 is equals to angle 5. Angle 1 is equals to angle 7. And angle 2 is equals to angle 8. So this is alternate angles. The first property related to parallel lines and transversal. Moving on to the another property which says corresponding angles are also equal when the lines are parallel. But what are corresponding angles? They are going to be on the same side of the transversal. Both the angles lie either in the left side of the transversal or they are going to lie in the right side of the transversal. Also, if one angle is exterior, then another angle is going to be in interior. Let us see how they look like. We are going to see over here in the same figure. If I choose angle number 1 now, you can see angle number 1 is lying in the right side of the transversal. So we are going to pick another angle coming in the right side only. Plus angle 1 is in exterior. So the another angle formed is going to be in interior. So here angle number 5 we are going to take. So 1 and 5 paired together are called as corresponding angles. And also class, if the lines are parallel, then they are going to be equal. Angle number 1 is equals to angle number 5. Another pair you can see here, angle number 2 and angle number 6. Another pair, angle 3 will be paired with angle 7 and angle number 4 will be paired with angle number 8. So there is also one trick to identify whether the angles are forming corresponding angles or not, and it is F formation. So if you see somewhere F formation class, then yes, we can say that the angles are corresponding angles. And also they are equal. So here angle 1 is equals to angle 5, angle 2 is equals to angle 6, angle 3 is equals to angle 7 and angle number 4 is equals to angle number 8. So this is the second property of parallel lines and transversal which says that if the lines are parallel, then corresponding angles are equal. And how to identify whether the angles are corresponding or not? You just check whether they are forming F. If they are forming F, then yes, the angles are going to be corresponding angles. Now moving on to the third property of parallel lines and transversal, which is a very important property here. It says that sum of the interior angles on the same side of the transversal is 180 degree. This is a very important property we have. So here we can also say all these angles as co-interior angles or consecutive interior angles. How they look like? Let us see here. The same figure we have. Now if I take angle number 3, as we are talking about interior angles, then again we are going to take another interior angle on the same side of the transversal. So if we choose angle number 3, the another interior angle on the same side of the transversal is going to be angle number 6, right? So angle 3 and angle 6 are co-interior angles, right? And what we say? We say that their sum is going to be equal to 180 degree. Very important property, that consecutive interior angles are equals to supplementary. They are supplementary. Their sum is equals to 180 degree. Now, can you see one another pair just like this? Yes, definitely we are going to get one another pair, and that is going to be angle 4 and angle number 5. So, angle 4 and angle 5 are also another pair of consecutive interior angles, and they are going to be supplementary. That means their sum is 180 degree. So, all these three properties are very important, class. They are going to be used for finding out the questions, right? For finding out the angles in the questions. Now, there is one note over here. We get the converse of what we have observed earlier, and that is, now all these three properties that we have discussed right now, there are some converse of all those three properties. What is the converse? Let us see. In the earlier property, we say that when the lines are parallel, then alternate angles are going to be equal. So, what is the converse of it? If the alternate angles are equal, if we find that in some figure the alternate angles are equal, then we are going to conclude, right? We are going to conclude that the lines are going to be parallel. So, here the first one says that if the alternate angles are equal to each other, or if the corresponding angles are equal to each other, or if the consecutive interior angles are supplementary, then what conclusion we can make? We can easily prove that the lines are parallel. So, here we can easily prove that the two given lines are parallel. So, this is the very important condition we have to prove in any of the question that the lines are parallel. How we can prove the lines are parallel? By showing alternate angles equal, or corresponding angles equal, or consecutive interior angles supplementary, right? We are definitely going to get the lines are parallel. So, here we say that none of these properties are observed when the intersecting lines are cut by a transversal. What are intersecting lines? Non-parallel lines. So, if we get non-parallel lines or intersecting lines like this, these are the two intersecting lines and they are cut by a transversal. So, in this figure, definitely we are going to get alternate angles and corresponding angles, but they will not be equal to each other, right? Alternate and corresponding angles are not equal to each other in intersecting lines. Also, consecutive interior angles are not supplementary in these type of lines. So, class, these were the concepts related to parallel lines and transversal. Now, we can easily solve some questions related to all these concepts. So, question number 1 here says that in the given figure below, AB is parallel to CD is parallel to EF. Then the value of X is, and the options are given to us. So, let us observe the figure first of all. Here we are having parallel lines. You can see all the yellow lines, AB parallel to EF and EF is parallel to CD. So, whenever we are going to have parallel lines, definitely we are going to get alternate angles or corresponding angles or consecutive interior angles. So, let us see how we can solve it. Let us take AB and CD together first of all. So, here we say that in the figure as AB is parallel to CD, with it we are going to take a transversal as BC, and BC is a transversal. Then we can say that angle ABC will be equals to angle BCD. Why? What is the reason? You can see these two angles are forming Z, as hence they are alternate angles. Therefore, angle BCD will be equals to how much? 56 degree. Now, let us take another pair of parallel lines, EF and CD. Now, as EF is parallel to CD, and here in this case, now the new transversal is going to be which line? Here we are going to take the new transversal as CE, right? The transversal has changed. Remember that. In these two parallel lines, we are going to consider EC as the transversal. So, when we have parallel line and a transversal, definitely we are going to get interior, consecutive interior angles. So here we can say that angle FEC plus angle ECD. Angle ECD is equals to 180 degree. Why? Because they are co-interior angle or consecutive interior angles. Solving it, we know the value of FEC angle, it is 152 degree plus angle ECD will remain as it is, equals to 180 degree, or angle ECD will give us how much? Subtracting 180 degree and 152 degree. Solving it, we are going to get how much? 10 minus 2 is 8, 7 minus 5 is going to be 2. 28 degree. Now here we need to find this x. We know the complete angle, also we know half of it, and that means some part of it. So how much is going to be x? X will be equals to complete angle BCD. Yes, from complete angle BCD we are going to subtract angle ECD, right? So here now for finding out the value of x, we can easily write that angle BCD minus angle ECD. Putting the values, we already know the values over here. It is 56 degree minus 28 degree. Solving it, 16 minus 8 is 8 and 4 minus 2 is 2. So here we have got the final answer as 28 degree, which is option number 1. So this is how, class, we can easily find out the answer. Moving on to the question number 2, what it says, let us see. In the figure below, AB is parallel to DE. So here we can again see the two yellow lines, they are parallel to each other. When we have parallel lines, we are definitely going to get alternate angles or corresponding angles or consecutive interior angles. Then the value of x is, and here we need to find the value of x, and this angle is representing the value of x over here. Now what we did in the figure is we have extended the line AB, and also we know that parallel lines remain parallel no matter how much they are extended, right? So we have extended this line AB till F. Clear? Now over here we can see the relation. We can say that as line AB is parallel to line DE, and with these two lines we are going to get a transversal as DF. DF is a transversal. Therefore, here you can see angle EDF. Angle EDF will be equals to angle DFA, and it is equals to 95 degree. Why? What is the reason? They are alternate angles. So reason is very important. You should know that why you are putting the two angles equal, right? So writing the reason is very important part. Here the two angles are equal because they are alternate angles. Similarly, here we can see another triangle formation, and inside the triangle we can easily find the angles. Angle ABC in triangle, which one? BFC. In triangle BFC, how much we are going to get? It is angle ABC plus angle CBF will be equals to 180 degree. Why? What is the reason? The reason behind is linear pair. They are linear pair. You can see these two angles are going to be linear pair. Putting the values, it is going to be 120 degree plus angle CBF as it is equals to 180 degree, or I can write directly that angle CBF will give us 180 degree minus 120 degree. Solving it, it is 60 degree. So here we have got the angle as 60 degree. Now again we can apply another property of a triangle, and that is exterior angle property of the triangle. What it says? It says that the exterior angle 95 right? This is the exterior angle. So, exterior angle 95 will be equal to how much? Sum of two interior opposite angles. And what are the two interior opposite angles we have? 60 degree and x. So, let us apply this property here. Also, angle DFA will be equals to angle FBC plus x. Why? What is the reason? The reason is exterior angle property. So, putting the values here, we are going to have 95 degree equals to 60 degree plus x, or solving it, 95 degree minus 60 degree is equals to x. So, 5 minus 0 will give us 5 and 9 minus 6 will give us 3. So, here 35 degree is going to be the value of x, which is option number 2 is the correct option. So, this is how class we can solve the questions by applying the property of parallel lines as well as triangle properties, right? Moving on to the next question here, it says that in given figure, if AB is parallel to CD and EF is perpendicular to CD, okay. So, let us show the information in the figure here. AB and CD are parallel. These two lines are parallel. After that, EF is perpendicular to CD. EF is perpendicular to CD. That means these all angles are 90 degree. Very important class. Whenever you see perpendicular lines, it means which angle is formed? 90 degree angle is formed. And angle GED. GED over here is GED. This complete angle we are getting equals to 126 degree. Then angle AGE. AGE angle over here is going to be how much, right? So, very easy. We can easily observe, just observe the figure and try to find the relation between the given angle and with the angle that we need to find out. So, can you see some relation between both the angles? Definitely yes. When the lines are parallel, and if I take GE line as a transversal, then angle AGFE is going to be equal to angle GED. Why? Because they are forming Z and also they are alternate angles. So, let us write it down here. As we know that line AB is parallel to line CD, also GE line will be our transversal. Therefore, we can conclude that angle AGE, that is what we need to find. Angle AGE will be equals to angle GED. And what is the reason behind it? It is alternate angles. Now, putting the values, we are going to get angle AGE. That is what we need to find out, equals to 126 degree. This is our final answer, which is option number 1 is the correct option. Moving on to the next question here, it says that in the given figures below, decide whether L is parallel to M. So, here there are two figures given to us and we need to decide whether they are parallel. So, how to decide the lines are parallel or not? What we do is we are going to check all the angles or one of the angles as in alternate angles or corresponding angles or consecutive interior angles, right? If alternate and corresponding angles are equal, then we are going to conclude that yes, the lines are parallel, right? If the consecutive interior angles are supplementary, then also we can conclude that the lines are parallel. So, let us see over here. It says that M and L are parallel when the consecutive interior angles are supplementary. So, let us add in figure 1. Angle 126 degree plus angle 44 degree will give us how much? Let us see. 6 plus 4 is 10, 2 plus 4 is 6 plus 1 is 7 and 1 more. So, it is equals to 170 degree. Definitely not equals to 180 degree. So, here we say that as consecutive interior angles are not supplementary. So, definitely in figure 1 the lines are not parallel. Therefore, L is not parallel to M. Moving on to figure number 2. Here we cannot see any direct relation between these two angles, right? They are not directly related as alternate or corresponding or consecutive interior. So let us find some more angles. As this angle is 75 degrees, right opposite to it we are also going to get 75. Why? Because they are vertically opposite angles, right? So vertically opposite angles are they, so therefore they both angles are equal. Now these two angles are related by consecutive interior angles. So how much is the addition? Let us see. In figure 2, we say that 75 degree plus 75 degree will equals to how much? Let us see. 5 plus 5 is 10, 7 plus 7, 14 plus 1, 15. 150 degree, which is definitely not equals to 180 degree. Hence, over here also class, line L is not parallel to M. So, none of the lines are parallel to each other. So, these are the questions class related to parallel lines and a transversal. I hope you all have understood it. Practice more questions. Thank you.